Hi, today we're going to study a circuit that comes up a lot when we start working with electric circuits. It's the voltage divider, or also known as potential divider. It is very easy, and what it does is convert a voltage or a potential difference that we have coming in to a lower potential difference coming out. So we can decide how much voltage we want to extract from our circuit just by changing the resistances that we have. So the potential divider is something like this. You have a battery or a cell here. You have a resistance here and another resistance here. And what you do is you are going to extract the potential difference from one of the resistances. This can be drawn in either one of them, and it works the same. Okay, so this is the potential difference that we're going to call V in, and this is the potential difference that we're going to call V out, and we're going to connect to a machine or to whatever we want externally. Okay, so I am going to show you the theoretical formulas that can be used in this circuit. I recommend you to just learn them for the exam because you shouldn't be trying to work out the formulas in the exam. You can, but why waste time? And it's a very easy formula. And afterwards, I'll show you a possible application of this circuit so that you know that with such an easy circuit, you can do a lot of fun things with such an easy circuit. So we're going to call this R1, and we're going to call this R2. As I said, it can be the other way around. So as there are two resistances in series, the total resistance is going to be R1 plus R2. We know that by Ohm's law, the intensity going through that circuit is going to be V in divided by the total resistance, which is R1 plus R2. Okay, so that's the intensity that is going to go through our circuit. And the voltage coming out of our circuit, of that resistance, is going to be, again, by Ohm's law, the intensity, which is V in divided by R1 plus R2, multiplied by the resistance that we have there, so that's R1. So if we rearrange that, we have V out equals V in times R1 divided by R1 plus R2, which is the formula that you should use in potential dividers. Again, as you see, it's 2 minutes to obtain the formula, but it's very easy to learn. So for the exercises, just get used to it instead of trying to find out the formula. Okay, so as you see, if R2, the other resistance, the one that we're not considering for the V out, is nearly 0, then we obtain R1, more or less R1 divided by R1, which is 1, and we obtain the same voltage out as we put into the circuits. V out equals V in. But if we increase R2, the more we increase R2, the more the denominator is going to increase, and so the more this R1 divided by R1 plus R2 is going to go to 0. The smaller is going to get, so as we multiply by V in, the V out is going to be less than V in. So by increasing that R2, we obtain a smaller voltage in our V out than we had in our V in. Okay, so it's an easy way to reduce our voltage, or and that's why they call it the voltage divider or potential divider. Okay, so what would be an easy application of this? Remember that we have many types of resistances, and two special resistances that we normally study are the LDR, light dependent resistor, and the thermistor. Both have very similar curves. If we draw the resistance in the y-axis, and in both cases, and in the LDR we draw here the intensity of light, and here the temperature in the thermistor, both have these types of curves. Okay, which is in the LDR with darkness we have very high resistances, and with light we have very low resistances, and the thermistor, when the temperature is low, we have a very high resistance, and when the temperature is high, we have a high resistance. So we're going to use this, and I'm going to show you with numbers an application of this. So imagine we have here 4 volts. The numbers are completely invented. And imagine we have, we're going to put the LDR here at the bottom. And then here at the top, we'll put a resistance of 5K or 5,000 ohms. Okay, so here we're going to have the LDR. Okay, and the LDR is going to change. At night is going to be 100,000 ohms, and during the day that's going to be, for example, 100 ohms, just to make it extreme. Okay, so what is going to happen here? If we put the LDR on where we considered R1, this was R2, we're going to see what happens at night. So at night, V out is going to be 4, which was the V in, multiplied by R1, which was 100,000, divided by R1 plus R2, which was 100,000 by 5,000, 105,000. That's 100 divided by 105 multiplied by 4, which is more or less 3.8 volts. Okay? So as you see, at night we have a high voltage, or a voltage which is very similar to the voltage that we had in our battery. Okay? So what happens during the day? Well, during the day, our V out is going to be 4 times 100 divided by 5,100. Okay, so that's going to be 4 divided by 51, which is going to be 0.08 volts, more or less. So with this type of circuit, if we use the LDR or the thermistor, but for example, if we use the LDR as R1, we have a circuit that at night will give us voltage. So for example, will turn on a light, and during the day it will give us barely no voltage, so it will turn off the light. So it can be one of those lights that we use during in the gardens, that are turned on at night and turned off during the day. Okay, so what happens if we put the LDR in the other position where R2 was? So that was 4 volts, and now this is going to be 5,000, and this is where we're going to use the LDR. Okay, and the out is still going to be this, and we'll see both cases. So what happens at night? So at night, in this case, we have V out is going to be 4 multiplied by, in the numerator we still have 5,000, and in the bottom we have 100,000 plus 5,000. Okay, so for 20,000 divided by 105,000, and that's V out equals 0.19 volts. So at night we have the opposite. At night we have a very low voltage. Okay, and what happens during the day? Well, during the day, V out is going to be 4 times 5,000 divided by 5,100. So that's 200 divided by 51, and that's the 3.9 volts. Okay, so if we change the LDR and we put it where R2 was, we have the opposite. We have a circuit that will give us voltage during the day and will not give us voltage during the night. So, for example, we can put this in a house appliance that we want to turn on during the day and not turn on at night. So as you see, we have, just by changing the LDR, we have seen two very easy circuits. One which will give us voltage during at night and not give us voltage during the day. Another one that will give us voltage during the day and not at night. And we can do the same with a thermistor depending on the temperature. Okay, so that is why this is a very interesting circuit and one that that people start to study a lot when they start to study digital circuits. I hope it helps.